So uh, welcome to all. And today we will discuss the chemical kinetics, very important chapter of physical chemistry. And myself, Dr. Navish Kumar Verma, and I have completed PhD organic chemistry. So first of all, I will discuss the what is the meaning of chemical kinetics. Okay. Okay. So, chemical kinetics, as name showing that it is the meaning of motion. You can say kinetics is synonymous word of motion or speed, you can say. So, it is basically applied on the chemical reactions. Okay, how the chemical reactions proceed, and does a chemical reactions takes place or not? Okay, so it tells about the kinetics and thermodynamics of the chemical reactions. Okay. So next is reaction speed. What is the meaning of reaction speed? So it is measured the change in concentration with time. Okay. So what is the changes of reactant when you conduct the chemical reactions? Next one is important factors affecting the rate of reactions. Okay. So there are following factors such as reactant concentration, temperature, action of catalyst, surface area, and pressure of the gaseous reactant or products. So all these factors affect the rate of chemical reactions. When you applied the concentration, much more concentration of reactant, then chances of collision will be much more. Okay, and kinetics will be also much more. When collision will be much more, then kinetics of molecules of the reactant will be much more. Okay, so also affect the rate of reactions. Temperature, when you increase the temperature, then kinetics as well as collision will be increases of the reactant. Possibility of products formation will be much more. Of action of catalyst, when you apply the catalyst, then what happen here? It lowers the activation energy. Activation energy is the minimum area in which reactant goes and it is converted into products. Okay, so what happens here when you applied the catalyst? It lowers the activation energy and help for conversion of reactant into products easily and with less time. Sorry for that. Surface area, if you increase the surface area of reactant, then possibility of collision with effective collision, you can say, will be much more. So that's why a possibility of reactant conversion into reactant to products will be much more. Okay. Pressure of gases reactant or products. When you increase the pressure, then chances of reactant converted into products will be much more. Then we will discuss the kinetics. Study the rate at which chemical process occur. Okay, so what is the rate of any chemical reactions by which is converted to reactant into products? Okay, so besides information about the speed, so all besides these factors, we will also discuss the mechanism of reactions, how a reactant is converted into products. Okay, so in between which what processes will be occur on the chemical reactions in which reactant is changes to the products. Okay. Next, we will discuss the some important. So we will discuss the importance points such as reaction rates, rate law. What is the meaning of rate law? Integrated rate law, half-life, RNA equation, and mechanism. So reaction rates tells about the measuring the rates. You can say I also defines earlier. Rates law. The rate depends on the amounts of reactant. Okay, so amount of reactant is much more amount of reactant, then what happened? Rate becomes low. Okay, so it also reveals the rate law. Integrated rate law. What is the how to calculate the amount of left our time to reach a given amount? Okay, so it is the integrated rate law. Half-life, how long it takes to take to react 50% of the reactant. Okay, so it is the half-life. RNA equation tells about the constant change with temperature. Okay, and mechanism reveals the link between the rate and molecular scale processes. Okay, so it is the some phenomenon I will discuss earlier. I will discuss later. So a reaction rate. So we will discuss the reaction rate. Okay, so if you see in this figure, there are three different figures, and the upper you can say mentions the time, and lower point indicate the concentration of reactant and products also. Okay, so when time is zero means initial phase when you conduct the chemical reactions at temperature zero, then there will be no products formation takes place. So by which the concentration of A remain constant. After 20 seconds, what happened? The concentration of A will be decreases and B will be increases. So similarly, as uh, as soon as possible, if you increase the temperature, if you increase the time, means after 40 seconds, concentration of A becomes lower as compared to B, and the concentration of B will be higher. Means if you see 0 second, concentration of B will actually here B product will be not formed. So there is no concentration of B. As soon as possible, after 20 seconds, A become decrease and some amount of B will be formed. And similarly, after 40 seconds, what happened? The concentration of A will be decreases and B will be concentration of B will be increases. Okay, so here reactant concentration of reactant will be disappear. So what happened here? Concentration of B will be reappear, you can see. Okay, so rate of reaction can be determined by monitoring the change in concentration of either reactant or products as a function of time t. Okay, so notation for stoichiometry, you can say it is denoted by change in concentration of A, concentration of reactant A, concentration of reactant B is denoted by this one. So in this reaction rates for the reaction in which A is converted to B, there are two ways measuring the rate. The speed at which the reactant disappear and the speed at which product appear. Okay, so two term is very important. A reactant disappear, then what happen here? Product appear. So it is the major concept. As the reactant disappear, then chances of products will be formation takes place, or you can say products will be appear. Okay, so reversible reaction kya hoti hai? In which first the reactant is converted to suppose that any chemical reactions in which A is converted to B, then what happened in chemical reactions, in reversible chemical reaction, B is again converted to A. So this such type of reaction is called reversible reaction. So as products accumulate, they begin to turn back into reactant. So it is the reversible reactions. Early on, the rate will depends on only the amount of reactant present. We want to measure the reactant as soon as they are mixed. Okay. A general way of measuring the rate of reactions is terms of change in concentration per unit time. So instantaneous rate is the change in concentration of A with time limits. Okay, limits to del change in concentration of A upon del T. So instantaneous rate is the change in concentration of A with time. Most common unit rate का molar per second. Molar is denoted by the moles per liter, so that's why unit will be the mole per liter second inverse. Okay. Next, reaction rate is the change in concentration of reactant or product with time, and unit is dependent by molar per second, or you can denote the molar second inverse. Suppose that this is the chemical reaction in which A is converted to B, where A is the reactant, B is the product. So rate what happen here? The B, because A is converted to B, so then concentration of A will be decreases and B will be increases. So decreases means minus sign will you will denote here, and B concentration of B will be higher, so that's why you can denote the plus sign. Okay, so del is reveals the change in concentration of A over time period del T. Del B denote change in concentration of del B over time period del T. So because concentration of A decreases with time, del A is negative. So you can also understand the reaction rate and stoichiometry. Okay, so what is the stoichiometry? This small a denotes the stoichiometry of the chemical reactions. Okay, so if you generalize, if you want to write down the reaction rate, then it is a general reactions in a stoichiometry is a small a. So you can denote the rate. So decrease in the concentration, decrease in the decrease in the stoichiometry. So -1 upon a change in concentration of A del upon with time del T is equal to क्या हो जाएगा -1 upon B. So you can see that stoichiometry will be 1, you can 1 by. Okay, so as C and D, the concentration of C and D will be higher, so that's why stoichiometry 1 upon C, change in concentration of C and change with time. Similarly, you can see this one. Okay, so it is the meaning of the chemical reaction is reactant will be decreases, so sign will be -1, and stoichiometry is write down in this way. Okay, and products will be increasing, means concentration of products will be higher as soon as reactant will be concentration of reactant will be decreases. So factors affecting the rate of constant we will discuss here. So the first factor is temperature. Any chemical reactions, if you increase the temperature, then chances of collision and kinetic of the chemical of the reactant molecule will be increases. So collision in between two reactant molecule will be much more when you increase the temperature. So by which kinetic energy of the molecules will be increases. So that's why chances of product will be formation will be high. Concentration of reactant, as the concentration of reactant increases, so the likelihood you can say the collision between the molecule will be increases and the chances of products formation will be high. Catalyst speed up the reactions by lowering activation energy. Catalyst, what happens, what play the role of catalyst means it lowers the activation energy by which products time taken by the reactant to conversion into products will be less. Okay. Surface area also affects this because more surface area, chances of collision will be much more and chances of product formation will be higher. Pressure of gaseous reactant and products also affects means if you increase the pressure, collision will be much higher and products formation will be uh, faster. Then we discuss the reaction rate examples. So simple, you can see this chemical reactions in which butyl chloride in presence of water converted to butyl alcohol and HCl. Okay, so a plot is drawn between the butyl chloride and time inverse means concentration of butyl chloride with time. Okay, so rate, as you can say here, initial rate is 0.10. Okay, and with time it decreases, concentration is decreases. So in this point, if you draw the graph, small graph, then concentration of A is higher. Okay, because time taken by the reaction will be less. As time increases, the concentration of butyl chloride will be decreases. Okay, so you can denote the del A upon del T or del A upon del T, you can say. Okay, so in this, this is the same. Okay, so rate here butyl chloride. So it is in this reaction, the ratio of C, this one is 1:1. Okay, means as soon as you can say C4S9 butyl chloride will be disappear, the chances of butyl alcohol will be same. Okay, formation will be same. So it is the 1:1 formation takes place in such type of reactions. Okay, so you can denote it by the rate minus be decrease in concentration of butyl chloride. So it is decreases, so the products will be increases, concentration of product will be increases. Okay, so it is the normal. Then reaction rate law. So in the next lecture we'll describe the reaction rate law. So it is the first lecture and I will discuss in the second lecture the remaining part. Okay, so thank you for all for watching this video, and if you like this video, please like and subscribe. If you have any queries regarding this, then please write down.